Hi, my name is Alistair. As many of you may know, I'm building a Monoposto or single-seater hill climb car from about the 1930s. I do, however, want a speedometer, and the mechanical arrangement for connecting up an Austin 7 gearbox to a speedometer will not give me the correct answers because the wheel size is different from the original gearbox. So I decided to buy an electronic speedometer, and I was not impressed with the fact that the speedometer was expensive enough, but it recommended a very expensive sensor, a Hall effect sensor, and I just wondered if there was an alternative. Here is the ETB speedometer. It's very nice, nicely made, a good quality part, and I want it to work in my special. Unfortunately, the only sensor they describe as using for it is a Hall effect thing, which you have to attach magnets to your prop shaft. I've just spent a fortune balancing my prop shaft. I don't really want to add magnets that might fly off at 6,000 RPM. So I'm looking for an alternative. This no-name magnetic sensor for a motorbike caught my eye. Thing that impressed me was that it's magnetic and it's an RPM speed transducer, and I wondered if that would work with the ETB speedometer. After receiving the device, I found that it performs very well, and it doesn't need magnets attached to the prop shaft, which I try to avoid if possible. See the setup. I've got this right angle drill that's driving this 8mm threaded rod. I've got something simulating the prop shaft flange, and I've got something simulating something added to the flange to stimulate the sensor, which is here. This is a motorbike electronic Speedo sensor, and this is the oscilloscope recording the results. And you can see that I'm getting 0.1, 0.2, 0.3, 0.4 volts, which should be able to drive the electronic speed. Here's the test rig with my DeWalt right angle drill and the thing ready, all connected up to the actual car. And here is the speedometer in the car, and I've calibrated it, and it's reading 0 miles per hour. If, however, I start up the DeWalt, you can see it works. Here is the results of my experiment. Basically, the speed reading with a 1500 rev per minute DeWalt should have been 39.8. I actually got 34. That's probably because I have no way of calibrating the DeWalt, so it probably is within reasonable tolerances. It would appear that this experiment is very useful.